Welcome to Pomodoro Joe for Tuesday, June 8th, 2023. Today we're looking at LeetCode problem 1502. Can make arithmetic progression from sequence. This is an easy problem. A sequence of numbers is called an arithmetic progression if the difference between any two consecutive elements is the same. Given an array of numbers R, return true if the array can be rearranged to form an arithmetic progression. Otherwise return false. And then they have an example here, 3, 5, 1. You can rearrange this to be 1, 3, 5, with 1 plus 2 being 3, 3 plus 2 being 5, return true. 1, 2, 4. We cannot rearrange this. So 1 plus 1 is 2, but 2 plus 2 makes 4. Those are not the same. All right. So with that, we will put 25 minutes on the Pomodoro timer and get started. So I think the easiest way to do this one is to simply sort our array and then check to see if the difference between all of our numbers is the same. So if you look at these, basically the arithmetic progression is saying the difference between any two consecutive elements is the same, which means that either you have a positive integer that's the same, so in this case it's 2, 1 plus 2 is 3, 3 plus 2 is 5, so you keep increasing by 2 every step along the way. You could have a negative integer, so you could be decreasing for every step along the way. Or you could have 0, where all the numbers are the same. But in any case, it seems like a sort will get us what we're looking for. So if your numbers are constantly increasing, well then that's a sorted array. If they're constantly decreasing, that's also sorted, but in a reverse order. So I think what we want to do here is sort our array, find the delta that separates, say, the first two numbers, and then we'll just check every single number after that to see if the delta is the same. Let's see, how many numbers? We're guaranteed at least 2, so that's pretty straightforward. Great. So the first thing we'll do is sort our array. Now I am going to create a new variable called sorted array, and I'll call sorted on the array, and it will return this new sorted array. So that's the Python way of doing this. Now, some of you might be thinking, well, you could make this faster by just saying array.sort. And that's true. If you call array.sort, however, it will be sorting this input array directly. So in Python, when you pass arrays to functions, they're passed by a reference. That means that this array that gets passed in is the exact same array. How do I explain this? So that means that there's just one array somewhere in memory, probably above this function call. That array exists in memory. And when you call this sort, you'll actually be sorting that array. You'll be modifying that memory location. Whereas when you call this sorted, that will actually create a new memory location with a new array of all the elements in this input array sorted in order. So it will actually be a completely separate array. So that does take more memory, and it will take more time to do all of this filling of that memory. But it means that you're leaving this input array unmodified, which is generally a good practice. So that's why I'm using this sorted array. All right, so now that we have our sorted array, let's find our delta. So this will be the difference between any two elements. So we'll take sorted array 1 and subtract sorted array 0. So that gives us our target delta that we need to look for as we go through the rest of our array. So now for every element in the rest of our array, we have to do the sorted array, and we'll go from element 2 to the end. Do we want to go 2 to the end? Yeah, we'll go from 2 to the end. So now we calculate our new delta and compare it to our existing delta. So if sorted array, interesting. I will need to keep track of the previous element. So let's do that here, actually. Our previous element. In this case, our previous element, because we're starting here at element 2, will be element 1. Now we've already done 1 minus 0. So now we'll be doing 2 minus 1, and then 3 minus 2, and 4 minus 3, etc., etc. So if our element minus our previous element does not equal our delta, well, then we can return false. That means that this delta, the difference between this element and the previous element, does not equal the delta that we're looking for, the one that we calculated from the first two elements. Well, then we'll return false. Otherwise, if we make it all the way through, then we'll return true. And there's one thing I missed in here. We need to update our previous element. So every time we go through this loop, our previous element becomes our element, or our element becomes our previous element, I should say. Okay, and I think this is it. So we will sort our array, but not in place. We will do a new array that is sorted. Then we'll take the first two elements, find their difference, store it in delta. Then we'll go through all the other elements, subtracting the previous element from the current element, checking against our existing delta, and if it doesn't work, if it's not the same, we'll return false. If we make it to the end, we'll return true. All right, let's see if this works. And that works. Let's see how we do. And we pass. And we do okay. We beat 61% for runtime and 20% for memory. So that's not too bad. Now there are things you could play around with in here to see if you can make any gains. Like, for instance, instead of storing this value in the previous element, you could just calculate the deltas directly in here. So we could actually try that. So in that case, instead of for every element, we will want every index in the range from the length sorted array to. So we'll have to do range length. So now we'll be using the index to index into our sorted array. All right. And then here, we'll actually have to do some indexing into our array and subtraction. So this will be sorted array at index I minus sorted array at index I minus 1. Now I feel like this should take longer because we're doing these calculations. We have to actually calculate an index and then reference the index, but we don't need to store this element in our previous. So it's a trade-off. We'll see if it works. Oh, I must have missed something here. Let's see. Oh, right. I need to start at element 2 and go to the end. So that's my problem. All right, let's try that again. All right, let's try this. This should work. I am clearly not thinking straight today. All right, let's see if this helps. And this one does pass, but it does worse for our runtime. It's only 39% for runtime and 20% for memory. It's about the same in memory, but about 20%, or no, 30% worse in runtime. So play around with this one. There's lots of different ways you can sort of tackle this problem. All right, I think that's it for me. Hope you enjoyed this. Hope you had fun. Hope you learned something. Hope you can go out and write better code.